Hello everyone again. In this short video we're going to look into how to convert a number from one system to the other. Like for instance, how do we convert a decimal number to binary, and how do we convert a binary number to decimal, and vice versa, and so on. So let's start with this number. Before we start, I'm just going to recap really quick on the radix, because which is the most important. Radix tells us how many unique values are possible in each number system. In decimal, we have 10 different values, so it has a radix of 10. Binary has a radix of 2. Octal has a radix of 8. Hexadecimal has a radix of 16. So with this, let's start and go from, how do we go from decimal to binary? So let's start with a number. Say I'm going to take a random number, 234, and we make it a habit of writing what is this radix here. This has a 10, and we need to convert that to binary. We don't know what it is. So let's start here. 234, it is quite simple. Take that number, divide it by 2, and look into the quotient and remainder. 234 divided by 2 has a quotient of 117, the remainder of 0. Now follow the same steps. Divide by 2, 117 divided by 2 gives me 58 with a remainder of 1. And take that 58 and continue that division. You get 29, the remainder of 0. Divide 29 by 2 and you get 14 with a remainder of 1. Now divide 14, continue this till you end up with a 0. 7 divided by 2 will give me 3, the remainder of 1. Divide 3 by 2 will give me 1 with the remainder of 1. 1 divided by 2 gives me a 0 and remainder of 1. Now, can we divide 0 by 2? Yes, we can, but it will still end up being the same thing. So continue this until the division where you have 2 consecutive zeros, and then stop. So once you do this, all what you need to do is take these numbers and write these down. Start from the top and go to the left. So this 0 goes down here, followed by a 1, followed by a 0, followed by a 1, followed by a 0, 1, 1, 1. And if you want, you can write these 2 zeros as well, and that's it. That is how you convert from decimal to binary. Now, how about converting from binary to decimal? Let's look into that. Binary to decimal. So I'm going to take a number, something like 10101, 2, and we need to convert that to decimal. So when we go from decimal to binary, we went from decimal to binary, we did the division, and the opposite. When we go from binary to decimal, we do multiplication, just like the opposite. So let's look into here. So what you need to do is 1 multiplied by 2 plus this first one multiplied by 2, next the 0 multiplied by 2 plus 1 multiplied by 2 plus 0 multiplied by 2 plus the last one multiplied by 2. And as you remember, start giving them powers starting from 0, 1, 2, 3, and 4. This gives you 1 times 16 plus 0 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1 gives me 16 plus 0 plus 4 plus 0 plus 1 gives us 21. This is decimal, and this is it to convert from one to the other. Now we looked into the integers. Now let's look into the fractions. How do we convert fractions? Now I'm going to take the same thing I'm going to look into explore decimal to binary, decimal to binary in fractions. Right? So the number we have is 0.573. We are given this in decimal and we need to convert that to binary. So here when we did the integers, what we did here was we did the division, and here this is going to be slightly different where you have to do multiplication. Don't worry too much. At initial thought these all looks confusing, but with practice and a few more discussions during class, this becomes intuitive and quite clear. Now let's look into this number here. We have 0.573. All what you need to do is repeatedly multiply the number. When we multiply this, we get 1.146. So take this one and write by the side. The value before the decimal, write it down. Take the remainder, 0.146 multiply by 2, we get 0.292. Take this number again, 0, and write it down here. Take the remainder, 0.292 multiplied by 2 will give me 0.584. Follow the same process. 0.584 multiplied by 2 will give me 1.168. Take this one and write it down. So you can keep on going this, but basically I would basically stop at 4 values, and once you write it, all what you need to do is the same way write it back. So here what you need to do is, since it's a 0 point, we all know it is going to be a 0 point here. Now the numbers, earlier when we wrote the numbers, we wrote from the right to the left, but here since the decimal, we're going to go left to the right. So in other words, whenever you write a number, whenever you take the number like any integer, you write the numbers away from the decimal. So you go from right to the left on the integer, and from the left to the right for the fraction. So this is integer, this is fraction. So as you see here, the first number you start from 1 is this one, the next one is a 0, the next one here is a 0, the next one here is a 1. So we write that 1. So our number 0.573 in the base 10 is 0.1001 in base 2. That is how you convert from decimal to binary. And one other quick conversion we're going to see is decimal to hexadecimal. This has a radix of 10, this has a radix of 16. So let's look into a number. I'm going to take a number, something like 3314 is a random number it took, and this has radix of 10. We need to write it in a radix of 16. So same as before, take this 3314 divided by 16 and find out the quotient and remainder. 3314 divided by 16 gives you a quotient of 207 with a remainder of 2. Take that number 207 divided by 16 again, you get a quotient of 12 with a remainder of 15. Then take this, continue this, 12 divided by 16, you get a quotient of 0 and remainder of 12. And here, now once you get this, look into these numbers. Look into these numbers and see if each number is representation of the unique values of hexadecimal. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, Then we don't have 10. We have A, B, C, D, E, and F. So basically, A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. So here, do we have 2 in hexadecimal? Yes, so we write it down. Do we have 15 in hexadecimal? No. 15 is represented by F, so we write F. Do we have 12 in hexadecimal? Yes, but it is represented by C, so we write it down. So once you do this, same as before, you start from the right, 2, then followed by F, then followed by C. So this way you can convert from a decimal to a hexadecimal. Now, with this, I will stop the number conversions, and we meet in the class. We're going to talk much more in detail on how to go from different number systems. So basically, we look from decimal to binary, binary to decimal, and we also look how to convert from decimal to hexadecimal. And later on, we're going to see how to go vice versa and how to go from one system to the other in detail. Thank you for watching this video.